Today we're going to take a look at this 2001 Volkswagen Vanagan. This Vanagan has a misfire. Now, to repair this misfire, the PCM has already been replaced and some of the injectors have been replaced. Now, if any of you are familiar with this VR6, putting the injectors in is no easy task. The vehicle still has a misfire. So we're going to take a look at it today to figure out a quick and easy solution to find misfires and identify the cause. The first thing that we need to do to repair this van is to find the missing cylinder. We're going to do that with the EMissfire Detector. We're going to use the amplifier and the tailpipe probe, and we're going to put those in the exhaust pipe, and this will allow us to identify the misfire to a cylinder or cylinders. So we're going to take the misfire amplifier and we're going to connect it to the tailpipe. And we're going to connect the cable to the tailpipe sensor so we can get a signal to the scope. We'll need 2 points of contact to identify the misfiring cylinder or cylinders. The first is the tailpipe that we just put in. That's going to go to channel 1. Channel 2 is going to go to a coil to identify where the cylinder location is. One very easy way to identify what wire we want to get into is to look at the wire colors that are going to the coil assemblies. As you can see, there's one color wire that's different. The end wire on this coil assembly is different. We're going to get into that wire on the number 1 coil. Now we can use any coil as long as we tell the EMissfire machine which coil has been chosen. In this case, we'll use number 1. Now that we've got the tailpipe transducer in the tailpipe and we've attached to the coil, let's let the EMissfire software identify what cylinder or cylinders are misfiring. Let's take a look at the software. First, we're going to open up the misfire software. Since we don't know what cylinder is missing, we don't want to use the compression yet. Go to misfire. We're going to go and we're going to pick out the type of vehicle, which is a Volkswagen. We're going to want to pick out our year. And our year is a 2001. Now we want to pick out a Vanagan. So here's our Eurovan. Now we're ready, so let's go over and pick the misfire tab. And the misfire tab is indicating that cylinder 3 is misfiring, and the misfire is occurring at 100%. We're going to come back over and we're going to look here. We can see that every time this light here is activated, which it's only activated as a solid light, indicating this is a dead miss on 3. Let's look at our software for the scan tool. The scan tool has no DTC set and all the monitors have run. The scan tool in the software is not able to pick up this misfire. That's been one of the problems for the shop that's been working on the car. Let's shut this Vanagan off so we can pull the spark plug out of number 3. This would be cylinder 1, cylinder 2, and cylinder 3. So I need to remove this coil and spark plug so we can do a compression check on this. These VR6 spark plugs are very difficult to get out because they go through the intake. We've already loosened the front assembly so the coil will fit out. They're very long and you won't get it out without having the front support loose to where you can get it back to get this out. We'll remove the spark plug and then we'll just install a basic compression hose. We're going to put the compression hose into the cylinder and tighten it. You just want it finger tight, don't get it too tight, just snug. We're going to connect the pressure transducer, it's a 300-pound pressure transducer, to the hose. We're going to also need a vacuum sensor put on here, so we're going to remove the vacuum line, and now we're going to install a vacuum pressure transducer onto a common port of an intake manifold. Now at the tailpipe, we want to make a change. When you're looking for a misfire, you want to dampen the exhaust pulses so it's easier to find what cylinders is misfiring. And we use the metal venturi. During this test, we know we have a misfire because we have the spark plug out and the coil out. Now we're going to want to use a straight hose, so we're going to remove the venturi. We're going to simply remove this, and we're going to put a straight hose on that won't dampen the pulsation. We're now slipping this into the tailpipe, and this will give us a much better understanding of the pressure during cranking, because one of the first tests that we need to do is a cranking compression test. So let's go take a look. Now that we have the tailpipe pressure transducer with the hose and not the venturi, a vacuum source supplying our -30 pressure transducer, and the 300-pound pressure transducer in cylinder 3, let's set the machine up so we can get the compression readings. First, we're going to take the 300-pound pressure transducer from cylinder 3, and we're going to connect this to our number 3 channel. We're going to take the vacuum port and connect it to 4. Once we have all our connections made, which we've already had the exhaust port on 1 and our ignition source on 2, now we have the 300-pound for a cylinder on 3 and the vacuum on 4. We will go in and we will select compression. The engine has already been selected. We will hit begin analysis. We are going to go to the measure and strip chart, so we're stripping. We're going to turn on the other 2 channels now so they're usable. Now we need to disable the system so we get a cranking waveform only. We don't want to start it quite yet. So let's go ahead and we're going to pull a fuse to disable the system. We've pulled fuse 18, which will keep this vehicle from cranking. We're going to crank the vehicle over now. And we want to allow it enough cranks to where we get enough data to see what's going on. Usually about 5 seconds. Now that we have the data saved, we're going to pause the data. We're going to take the zoom window. We're going to come in on zoom, and we're going to blow these up. Right away, is what I want to show you is we only have 75 pounds of cranking pressure. The big drop on the exhaust opening compared to the intake is a clear sign that I have a cylinder leakage problem. So what we're going to do is we're going to take the cursors and we're going to mark the bottom of the exhaust pocket to the bottom of the intake pocket. Right here I have 5.2 pounds of pressure difference between the intake and exhaust. This clearly shows that I'm leaking. Anything more than 2 pounds is a problem. We're going to now zoom in on this so we can better figure out where our problem is. We're going to turn on the intake pulse, and we are going to mark our cursors through the compression strokes. Take the zoom window, and what we want to look at is the tailpipe exhaust and the intake manifold vacuum during crank. Now right away, this is the exhaust pulse. Do you see how even all of these are? They all look the same. But look at the intake. Do you see how the intake has a pull, has a pull, has a pull? Now right here is where the intake valve on this cylinder, number 3, opened. So this is the pull from number 3 right here. It's very good. It's even with all the others. What you see is when this guy comes up, he drops down. Again, you can see that I had a drop. That's due, this is the mark where we came up on compression. The intake valve opened here and closed here. When the intake valve closed and I went up on a compression, the intake valve is leaking. So as the piston comes up on pressure, it forces that pressure into the intake manifold, creating this downward turn and a lower. So what we have here is an intake valve leaking. So we need to remove this head, and we're going to have to repair a valve. As you can see, this 2001 Vanagan had a very tough problem. The shop that had been working on it has replaced and swapped injectors, coils, computers for really what should have been a 10-minute diagnosis. As you can see with the EMissfire, we identified the cylinder correctly. We identified the problem being the intake valve correctly. There's nothing else that's going to fix this car. And since this problem is somewhat intermittent when it's cold, this testing was also done cold. If you would have allowed this engine to warm up and done a compression test, it would have tested fine. The intake valve is leaking. Now the EMissfire detector easily and rapidly identified that cylinder 3 was misfiring, and then by removing the plug it identified what the problem was. It's an intake valve. Replacing all the parts in the world on this engine isn't going to fix this misfire. What your shop needs is the right diagnostic equipment. ATS can provide you with cutting-edge technology that will save your shop time and money.